Welcome to the Explainer. So, if you're building the next big AI tool, you are in exactly the right place. Today, we're unpacking the ultimate playbook for taking your AI prototypes and turning them into incredibly scalable, production-ready SaaS applications for 2026. We're skipping the beginner stuff, we're going straight into the actual architecture, the advanced prompt engineering, and the security patterns that top-tier engineering teams are using right now.
But before we get into the weeds, let's kick things off with a pretty provocative question. Why do 90% of AI wrappers absolutely fail at scale? Look, building a basic CRUD app or a simple AI wrapper, it's incredibly easy today. But scaling it, that is where founders hit a brick wall. When you suddenly have thousands of concurrent users, you're managing these long-running LLM tasks, and you're desperately trying not to bankrupt yourself on GPU costs, well, the naive beginner approach just falls apart completely.
It really boils down to the amateur approach versus production reality. The amateur setup relies on direct, slow, and honestly insecure LLM calls. The front end literally just sits there waiting for the back end to finish thinking. A true production sauce, on the other hand, relies heavily on asynchronous queues, aggressive caching, and strictly isolated vector databases. It completely decouples the lightning-fast parts of the app from those heavy, slow AI inference layers. All right, here is our roadmap for today. We're going to dive into this blueprint layer by layer. Number 1, the scalable architecture blueprint. 2, engineering the perfect agent. 3, the prompt caching revolution. 4, multi-tenant AI security. And finally, production scaling and monitoring. So let's jump right into layer 1, the scalable architecture blueprint. Fast front end, slow back end. The golden rule here is decoupling. Think about it. When a user clicks generate, they expect instant feedback. But LLMs, they can take 10 to 30 seconds to reply. If 100 concurrent users click generate at the exact same time, there is no way you can spawn 100 instant LLM calls without crashing your server or hitting massive API rate limits. Instead, you have to push those requests through a highly resilient asynchronous queue architecture. The user's request hits your API, and it immediately pushes the job into a Redis queue. Then, a completely separate Python worker picks up the job when it's safe and executes the LLM call. Meanwhile, your app stays incredibly fast and responsive. The modern 2026 tech stack is fascinating, especially when we talk about the memory layer. Postgres with PG Vector. For about 95% of use cases, you simply no longer need a separate, overly complex vector database. You can unify your relational user data and your vector embeddings inside a single database. For developer experience and overall architectural simplicity, it's an absolute dream. I love this metaphor. Think of your API layer as the bouncer and your AI worker as the thinker. Your Node or Go API is the fast bouncer. It's standing at the door, handling thousands of web connections, checking authentication, enforcing rate limits. It absolutely does not let users touch the AI directly. Behind the velvet rope is the thinker, your Python fast API service. It sits safely behind the queue, quietly and reliably churning through heavy intelligence tasks. If that AI service hangs for some reason, your main website doesn't even blink. It stays completely up. But hey, nobody wants to stare at a blank screen while the thinker is doing its job, right? That's where streaming responses come in. You've got to render the response token by token using server-sent events. It gives the user that perceived speed. But a quick word of caution here. You probably want to avoid the edge runtime if you need full Node.js streaming capabilities for robust logging. Oh, and absolutely always handle cancellations with an abort controller. If a user clicks away from the page, kill that request immediately. It stops token generation and literally saves your cloud budget from spiraling out of control. Moving on to layer 2, engineering the perfect agent, specifically focusing on system prompts. Like crafting a system prompt isn't some dark art. It's not about voodoo prompt engineering, magical incantations, or buttering up the AI by telling it it's a world-class expert. It is strictly about establishing a highly predictable environment. Research from reverse engineering tools like Claude Code shows that LLMs actually have a U-shaped attention curve. They focus really heavily on the very beginning and the very end of your prompt, and they kind of zone out in the middle. Because of this, you absolutely must put your identity and hard safety boundaries at the top, sandwich your core workflow in the middle, and then, this is crucial, repeat your most important safety rules as reminders at the very bottom. The core philosophy of agent engineering really boils down to this single idea. An agent is just a model. You have to actually trust the model to reason, to plan, and to execute. You aren't building some rigid mechanical pipeline anymore. You are designing an environment where the model can autonomously do its best work. And because we're trusting the model, we need to give it overarching principles, not super rigid step-by-step procedures. Think about it. If you give an LLM a strict 20-step checklist, it's going to execute it mechanically, and the second it hits an unexpected edge case, it will completely freeze. Providing strong principles instead allows the model to naturally adapt to those weird edge cases on the fly. All right, layer 3, this is a big one, the prompt caching revolution, or how to save up to 90% on your tokens. If you are running long-running agentic products, prompt caching dictates basically everything. It determines your operating costs and your latency. A great cache hit rate can literally cut your token costs by 90%. But here is the catch. Caching is incredibly fragile. The single biggest amateur mistake we see is developers dropping a dynamic timestamp right at the top of their system prompt. That is a massive cache breaker because that timestamp changes every single second. Your cache is instantly invalidated every time. The production best practice, the cache saver, is to place all your static, unchanging context right at the beginning and hide any dynamic content at the absolute very end. Here's the technical reality of why that happens. Prompt caching works through something called prefix matching. The API caches everything byte for byte, right from the very start of your request. Any change, anywhere in that prefix, completely blows up the cache for everything that comes after it. Practically speaking, this means you should never, ever add or remove tools mid-session. Doing that alters the prefix and breaks the cache for the entire ongoing conversation. So what do you do when you need to give the agent new instructions on the fly without breaking the cache? You use mid-conversation context injection. It's this brilliant progressive disclosure technique. You inject XML tags, like a system reminder tag, directly into the user's messages to fight context rot. You can use it to switch the agent into plan mode or to notify that a file just changed. It is an absolute pro tip because it seamlessly updates the agent's behavior while perfectly preserving that highly valuable static prefix for massive cache hits. Let's move to layer 4, multi-tenant AI security and isolating your data. When you're building B2B SaaS, you are obviously handling multiple clients. If a medical record leaks or an internal competitor's pricing sheet magically appears in the wrong user's chat, that's it. That is a business-ending event. Multi-tenant AI is absolutely not just regular multi-tenancy with an LLM slapped on top. The sources are incredibly stark about this warning. You aren't just isolating simple database rows anymore. Your vector embeddings, your model context windows, and frankly, even your inference costs all demand strict, distinct isolation on a per-tenant basis. Now, depending on your scale and compliance needs, top architects are generally choosing between 3 production isolation patterns. If you've got under 100 tenants and you need hardcore compliance-grade security, you go with a separate collection per tenant. If you need high scale, you use metadata-filtered shared collections. But here's the kicker. You have to enforce those filters strictly at the SDK boundary so your developers can't accidentally forget to apply them. And third, you can partition by jurisdiction, which is great for sharing large regulatory text across specific regions. Whatever you do, please isolate at the infrastructure level, not the application layer. Relying on application-level where clauses is exactly how catastrophic leaks happen, because it just takes one developer forgetting to add it to a query. You need bulletproof infrastructure-level isolation. We're talking Postgres row-level security and tenant namespaced Redis cache keys. Do not leave your company's entire security posture up to human memory. Finally, layer 5. Production, scaling, and monitoring. Let's talk ops and costs. Okay, so what actually happens when your app goes viral? You get hit with hundreds of requests a minute, and you slam right into Anthropic's strict rate limits. Well, here is the life cycle of a request under heavy load. The request hits that Redis queue we talked about earlier, and immediately the system performs a token and request limit check. If the API says you're rate limited, your system must execute an exponential backoff with jitter. This prevents cascading failures across your network. It waits a bit, it retries intelligently, and then it logs all those performance metrics straight to your dashboard. When you put all this together, the financial impact is literally game-changing. By leveraging automatic caching, say through Vercel, and hooking it up to Grafana Cloud's token monitoring integrations, your ROI visibility becomes incredibly clear. You can visually track that massive 90% cost savings from your cache tokens while zeroing in exactly on which specific tenants are driving that remaining 10% of uncached costs. So I want to leave you with this thought. Is your AI architecture genuinely ready for 2026? It might be time to take a really hard look at your code base, ditch the naive AI wrappers, and start refactoring toward this robust, scalable, production-ready blueprint. Thanks so much for joining me on this explainer, and happy building.